There's the theme music. Okay, podcast 11D. Solve stoichiometry problems by using the box method. This is going to be kind of the cumulative, putting all this together that we've done into solving a stoichiometry problem, an overall problem. So, Coach Forster, you want to set this up, and I'm going to get started figuring these molar masses so that we've got them when it's time to go.
So what is it showing you in the top boxes here is telling you the names of each compound. So this is a formula for K2SO4 plus PbNO3 with an arrow gives you KNO3 plus PbSO4. So since we're so good at doing types of chemical reactions, you'll notice that immediately, I'm sure, that this is a double displacement, no doubt about that. But we have K2SO4 and PbNO3. The K and the Pb switch places, so now we've got KNO3 and PbSO4. The first thing you want to do with these is balance this equation. So here we've got two Ks, and over here we've only got one, so I'm going to put a 2 in front of that. We also have one SO4, one SO4, one Pb on the right, one Pb on the left, and then two NO3s and two NO3s. So the rest of these are just ones. All right, with 1, 2 down there. All right, what you want to do is transfer these numbers to in front of the box that you're talking about here. So molar mass is the next thing you need to fill out, and Coach Arthur, I think, calculated all those
Got
for
them
us.
ready. The first one, I went through the periodic table and just calculated these. 174.3.
Okay.
331.
331.2.
101.1.
101.1.
And 303.3.
303.3. All right, that sounds like we're numbering off radio stations there.
Yeah.
Okay, so now, as we move down, we filled out the top one, filled out the next one. Now we're going to fill out the grams, or you're going to start out with whatever's given to you. So you want to go from grams to moles here.
Because remember, when we go to moles, that's what connects everything together.
Everything connects
go to moles.
through moles.
So do you remember how we did that on our...
Yes, I think so.
This goes back to your flow chart, guys, that we did in about the second video. Okay, so you can grab that flow chart and look, but we're going from grams to moles. What does it say to do?
We're going to divide by the molar mass.
We're going to divide by the molar mass.
So 174.
And so this is why it's important to have those molar masses up there, because you're going to need them at some point.
Right.
You might as well just have them ready to go. So 25 divided by 174.
Those grams go away.
We get 0.14 moles. Okay? And that's a pretty... That's a number you'll get very regularly from moles as a decimal, so that's nothing to worry about that it's too small or anything.
Right.
That's a pretty normal number for moles.
So now the whole thing with stoichiometry is that now I can compare these moles to the other substances that are in my formula.
Because your coefficients are important now.
Yeah, your coefficients are important.
They mean more than just the balancing, which is all we've used them for up until now.
Right. So notice you have 3 1s up here. All right, and those 3 1s are going to be equivalent to whatever the mole amount that is attached to it. So one mole of this is actually equal to 0.14 moles. So wherever you have a 1, your moles are going to be 0.14.
It's like a ratio.
Yeah, see, that's your ratio there.
So any of them that have the 1, they're going to have the same number of moles.
Right.
Okay. Now what about that 2?
The 2, okay, it's going to tell you, well, I'm going from 1 to 2, so I'm going to up my ratio by 1. Okay, so 1 to 2, I still want it to equal 1, so it's going to be 0.28 moles for that. Okay. So I just took that 0.14 and multiplied it by 2.
Because it had a ratio of 1 to 2 rather than 1 to 1.
1 to 1.
All right.
All right, now we need to...
Coach, our ultimate goal of this problem, obviously, is to find the number of grams of everything.
Right.
And so we had to find the moles to be able to do that.
Right.
Okay, so let's go find the grams of these. So now in your flow chart, we're going moles to grams. What's it say to do in that case?
You're going to multiply.
We're going to multiply. So 0.14
times 331.2.
And so we have 46.4
moles. And those moles those moles cancel out, so I'll be left in grams.
46.4 grams of lead nitrate.
All right.
Right here we've got 0.28 times 101.1.
Okay.
So we end up with 28.3 grams.
Okay.
And in our last box, 0.14 times 303.3, and we end up with 42.5 grams.
Okay.
And so there was a full box problem.
A full box problem. And if you add these up, 25 plus 46.4, and then 28 plus 28.3 plus 42.5, those should be equal numbers, right?
Right, we're a little bit off, but you're going to be off by anywhere within maybe 0.5 or so.
Right, just depends on where you round.
The rounding on the number of bowls and all that will cause a little error there, but it should be. You can always double check that and make sure you're within at least maybe one whole number or something like that.
Yeah, because law of conservation of mass says you should have the same two numbers on each side.
And again, we're not carrying out all 15 decimals that we may have there, but we are rounding. So.
Yep. And I think that wraps up our unit on stoichiometry. I think we said all we need to say about it. I think we said our piece, and Mr. Mole Man can go live in peace. So, and his Technicolor
anything else?
Chemistry coat. No, I think that's it.
Clear your screen, Coach Forster.
All right.
Just for fun, one more time.
Oh. All
right. We'll see you guys next time.